Hello everyone, today we are going to learn about solutions to linear equations. So you can see here that I have this linear equation y equals 2x plus 1, and over here I have the graph of that linear equation. And basically a solution of this equation will be a point, any point, that's on the line. So just by looking at the graph, I can see that 1, 3 is a point that's on the line. So 1, 3 is a solution to y equals 2x plus 1. But that's not the only solution. I could quickly see that, for example, negative 1 is a solution because this point right here is a point that's on the line. And they don't always have to be integer numbers. So I could have something like 0.5, comma 2, and that point is also on the line, so it's also a solution. We could just as quickly identify points that are not solutions by checking to see if they're on the line. So like 3, 1 is not a solution because this point right here is not on the line. Let's pick another one just for fun. I can see that negative 2, 1 is not a solution because it is not on the line. Right? So to recap, 1, 3, 0.52, and negative 1 are solutions, and these points, negative 2, 1, and 3, 1 are not solutions to this linear equation. All right, in our last example, we had a linear equation in slope-intercept form. Now we have an equation in standard form. We have 2x plus 3y equals 6. And we're going to look for solutions to this equation. And it works exactly the same way. And I could see some pretty easy points to determine that they are solutions right here. Oh, that's just the y-intercept, so no problem. That is a solution. I could see that 3, 0 is a solution because that's the x-intercept. But those aren't the only ones. I could see something like, let's say, negative 1.5 and negative 1.53. I think this is a solution. Yeah, there we go. All right, those 3 points would be solutions. And we could easily see something like 2, 3 is not a solution. All right, so to recap, negative 1.53 is a solution, 0, 2 is a solution, 3, 0 is a solution, and 2, 3 is not a solution. And you're probably thinking that there are many, many, many different solutions. So any coordinate that would be on this line would be a solution to this linear equation. And there are an infinite number, an uncountable number of solutions to this linear equation. All right, let's move on and we're going to take some notes. So let's write this down, 4.0, solutions to linear equations. And this is page 1 in our notes. All right, I'm going to graph this equation y equals 1/2 x minus 1. I have my 4x4 graph set up, and I'm going to start at negative 1 because that is the y-intercept. The slope is 1/2, so I'm going to go up 1, right 2, up 1, right 2. And I'm going to write down 3 points that are solutions. I could see quickly that this point, the y-intercept 0, negative 1, is a solution. I can see that this point, the x-intercept, that is 2, 0 is a solution, and I could see that this point right here, 4, 1 is a solution. So it's very easy for us to find solutions. And then here, I'm going to write some that are not solutions. Sometimes they abbreviate solutions like this. So any point that's not on the line is not a solution. Quickly right there, I could see that this point 1, 2 is not a solution. There are lots and lots that are not solutions. All right, now we're going to determine algebraically if a point is a solution. So I have this equation, y equals 1/2 x minus 1, like we saw above, and the point 6, 2. And sometimes we don't always have a graph, or it would be very difficult to graph the equation to see if a point is a solution. So what we do is we plug this point into our equation and we evaluate. And if both sides are equivalent after we evaluate, then the point is a solution. So let's see how that works. So I'm going to plug in here for y, 2, and I'm going to determine if that is equal to 1/2 times, well, for my x that matches with the 2, it's going to be 6. Okay, so I want to know, is this true? And so I'm going to have 2 is equal to 1/2 times 6. You can probably do that pretty quickly and see that it's 3. So I have 2, and I want to see, is 2 equal to 3 minus 1? Well, yeah, we know that 2 is equal to 2. So that means that 6/2 is a solution. All right, let's try another point. Let's do the same thing. Y equals 1/2 x minus 1. And let me do the point, let's say -2, 1. Is this a solution? Not so sure. So I'm going to plug in some numbers right here, and I'm going to determine, are these solutions? So I'm going to plug in 1 for my y, I'm going to plug in -2 for my x, and I'm going to see, are both sides equivalent after I evaluate both sides? Well, I don't have to do anything here, that's just 1. 1/2 times -2 is going to be equal to -1 minus 1. So are these equal? Well, is 1 equal to -2? No, those are not equal. So we can see that -2, 1 is not a solution. All right, and if we look back to our graph, this point, -2, 1, -2, 1, that's right there. That would not be a solution. We can tell that pretty quickly and easily. This point, 6, 2, if we extended the graph, 1, 2, 3, 4, 5, 6, 2, we can see that this line would probably extend and pass through that point. All right, so that's how we determine to see if points are solutions to linear equations.